Modern Age MCQs, Physics Class 2nd Year, Unit number 13, Electromagnetism, Part 2. The unit of magnetic induction 1 Gauss is equal to option A 10 power minus 2 Tesla, option B 10 power minus 3 Tesla, option C 10 power minus 4 Tesla, option D 10 power minus 6 Tesla. The key is 10 power minus 4 Tesla. Therefore, the correct option is C. Reason: Gauss is a smaller unit of magnetic induction. Tesla T and Gauss G are related as 1 G is equal to 10 power minus 4 Tesla, or 1 Tesla is equal to 10 power 4 G, where G is the Gauss. Hence, the magnetic induction 1 Gauss is equal to 10 power minus 4 Tesla. The SI unit of magnetic flux density is option A Newton ampere meter, option B Newton per ampere meter, option C Newton per ampere per meter, option D Newton ampere per meter. The key is Newton per ampere per meter. Therefore, the correct option is C. Reason: magnetic flux density is B, which is equal to magnetic flux divided by area, phi divided by A. In SI unit, B is Weber per square meter, which can also be written as Newton meter per ampere into per meter square, where Newton meter per ampere is the unit of the flux, which is equal to Newton per meter per ampere. Hence, the SI unit of magnetic flux density is Newton per ampere per meter. A charged particle of 2 coulomb is placed in a magnetic field of 4 Tesla at rest, experiences a force. Option A 0 Newton, option B 2 Newton, option C 4 Newton, option D 6 Newton. The key is 0 Newton. Therefore, the correct option is A. Reason: magnetic field cannot energize a charged particle surrounded by electric field. Hence, a charged particle in a magnetic field at rest experiences no force, which means that the force acting at the particle is 0 Newton. Note: only like fields can interact with each other. For example, electric field interacts with the electric field and magnetic field interacts with the magnetic field. Electric field cannot attract with the magnetic field. Therefore, the charged particle at rest remains at rest in a magnetic field. A charged particle of charge Q is projected in a magnetic field B at angle theta with the velocity v. The force F acting on the charged particle is option A Q into V dot B, B Q into V cross B, C Q square into V dot B, V Q square into V cross B. The key is Q into V cross B. Therefore, the correct option is B. Reason: the force acting on a current carrying conductor in a magnetic field is F is equal to I into L vector cross B vector, or F is equal to Q divided by T into L vector cross B vector, where Q divided by T is equal to the current, or F is equal to Q into L divided by T into B, or F is equal to Q into V cross B. Hence, the force acting on the particle is F is equal to Q into V cross B. The force on a charged particle moving parallel to magnetic field is given by option A, F is equal to 0, option B, F is equal to QVB, option C, F is equal to BIL, option D, F is equal to Q into E. The key is F is equal to 0. Therefore, the correct option is A. Reason: force acting on a charged particle is F vector is equal to Q into V vector cross B vector, or F vector is equal to Q into VB sine theta into n unit vector with the magnitude F is equal to QV B sine theta. As theta is 0, therefore F is equal to QVB sine 0, or F is equal to QVB 0, which is equal to 0 because sine 0 is equal to 0. Hence, the force acting on a charged particle is F is equal to 0. A charged particle moving perpendicular to a magnetic field experiences a force. Option A, F is equal to 0. Option B, F is equal to QVB. Option C, F is equal to BIL. Option D, F is equal to Q into E. The key is F is equal to QVB. Therefore, the correct option is B. Reason: force acting on a charged particle of charge Q is F vector is equal to Q into V cross B, or F vector is equal to Q into VB sine theta into n unit vector, where VB sine theta into Q is the magnitude of this force, or F is equal to QVB sine 90 because theta is 90. Therefore, F is equal to QVB. Hence, the force experienced by a charged particle is F is equal to QVB. What will be the force in Newton acting on an electron traveling with 10 power 7 meters per second at 90 degree to a field of 0.2 Gauss? Option A, 0.2 times the charge of electron. Option B, 50 times the charge of electron. C, 100 times the charge of electron. D, 10 power 7 times the charge of electron. The key is 100 times the charge of electron. Therefore, the option C is correct. Reason: the force acting on a charged particle is F is equal to Q into V cross B, or F is equal to E, where E is the magnitude of the charge of the electron, into V cross B. Therefore, the magnitude of force acting on electron is F is equal to E into 10 power 7 into 0.2 into 10 power minus 4, because 0.2 Gauss is equal to 0.2 into 10 power minus 4 Tesla into sine 90. Sine 90 is 1. Simplification gives F is equal to 100 times E. Hence, the force acting on the electron is 100 times of its charge. The force acting on an electron traveling with 10 power 7 meter per second parallel to a field of 10 power 3 Weber per square meter is option A, 0 Newton, option B, 50 Newton, option C, 100 Newton, option D, 1000 Newton. The key is 0 Newton. The correct option is A. Reason: the force acting on a charged particle is F is equal to Q into V cross B, or F is equal to E into V cross B, because the charge of the electron is denoted by E. The magnitude is F is equal to EV b sine theta. Therefore, F is equal to EV sine 0 because the electron is traveling parallel to the magnetic field. Theta is equal to 0 and sine 0 is equal to 0. Therefore, F is equal to 0 Newton. Hence, the force acting on the electron is 0 Newton. An electron in a uniform magnetic field with constant speed follows option A, spiral path, option B, circular path, option C, helical path, option D, elliptic path. The key is circular path. Therefore, the correct option is B. Reason: a particle moves with constant speed either in a straight line or in a circle. In the absence of force, particle moves in a straight line according to first law of motion, but in a field it moves in a circle with constant speed. The magnetic field provides centripetal force to the electron. Hence, the electron moves in a circular path. A proton revolves in a circle of radius r in a region of uniform magnetic field B with time period t equal to option A 2m divided by b e, where m is the mass of the proton and e is the charge of the proton. Option B, pi m divided by b e. Option C, 2 pi m divided by b e. Option D, b e divided by 2 pi m. The key is 2 pi m divided by b e. Therefore, the correct option is C. Reason: the force which keeps the proton in a circle is F is equal to EVB, and the centripetal force is Fc is equal to mv square divided by r. This magnetic force is equal to the centripetal force. Therefore, the protons revolves in the circle. Therefore, we can write EVB is equal to mv square divided by r. Simplification gives V divided by R is equal to BE divided by M R. Omega is equal to BE divided by M because V divided by R is equal to omega, or you can say that it is the relation between the linear speed and angular speed. Or we can write 2 pi by capital T, which is the time period, because this is the relation between the angular velocity and the time period. Therefore, the time period is equal to 2 pi m divided by b e. Hence, a proton revolves in a circle with time period 2 pi m divided by b e.